Okay, hey class, I wanted to go over this last page of the notes of descriptive statistics and then go into Excel and actually do all of these things. So this is just a summary of the things that are in this descriptive statistics set of notes. And then we'll use this M&M data that we'd played with, or that we had made on the first week of class. So here we go. We talked about 3 measures of central tendency. Remember central tendency, that's sort of like the word central is like the middle. So what are 3 measures that we can use to kind of come up with one number that describes sort of what's most likely to happen, or what's expected to happen, or what's kind of in the middle, central, that kind of idea, right? So the 3 of these are easy. This is mean, median, and mode, right? Median and mode. And then we talked about the 3 different measures of location. And location, we mean really where in the set of data is something, right? So, for example, I talked about when you take your child to the doctor and they weigh them or measure them or whatever, then they usually tell you this: your child is, the 90th percentile in weight or height or head size or something goofy like that. All right, so this is just a measure of location. Where is it? And there was really 2, but they were kind of the same thing. First one was percentile, and the second one was quartile. And quartile, we said, well, percentile can be anything. So I can have like 17th percentile or 23rd or 93rd. It has to be between 1 and 100, obviously. The quartile, there's really only 2, kind of 3. The first quartile is the 25th percentile. Quartile means like quarter. Think of that, quarter, quartile. 25th percentile. And then the third quartile is the 75th percentile. Now, there is a second quartile. I skipped a second, but the second quartile is just the median, right? The guy that's right smack dab in the middle. All right, so that was that. What else? We talked about measures of variation. We said there was really 4 measures of variation that we discussed, but really 2 of them were very close to each other. The first 2 then was variance and standard deviation. And we said they're really, really close because one is just the square root of the other. Standard deviation. Sorry, I can't talk and write at the same time. Standard deviation. But we typically are going to use standard deviation because it's in the same units of our original data, right? Where variance is in some kind of squared units of our original data, which most of the time doesn't make a lot of sense. Right, so we talked about weight of M&M bags. If that was our measure, variance would then be the square of the units would be the square root of weight of M&M bags, which is just not very helpful by itself. But if we take the square root of the variance and we get the standard deviation, and it is back in the original units. And we said the standard deviation is, remember, intuitively is the average distance from the mean. All the points that are there, how far away on average are they from the mean? Deviation means difference. How far do they deviate from what was expected or what the mean was? What was the standard deviation? The standard or sort of the average difference. So intuitively we think, standard deviation is just how far away things are from the mean on average. Intuitively. That's not quite right, remember, because we end up squaring it and then taking, finding the difference and then squaring it and summing those all up and then taking the average of the squared deviation from the mean and then the square root of that. But intuitively, we're going to try to think about the average. All right, the other 2 then were range, which was just the max minus the min, and then this guy's called interquartile range. That's a Q. Quartile range. Sometimes you'll see this as written as IQR, interquartile range. Interquartile range then is the distance. Well, remember, range is the distance from the biggest point to the smallest point. So interquartile range then actually just sort of shrinks that down and says, well, instead of taking these sort of extreme points, which might be outliers, there might be something really big out here, let's just move it in a little bit and just look at the 25th percentile and the 75th percentile and find the range in between those 2 points. So that's what the interquartile range. It really gives us the distance for the middle 50% of the data. How far away are the middle 50% of the data from one another? Interquartile range. All right, last thing we sort of talked about were these measures of association. And we said there was 2 of them, correlation and covariance. Very similar covariance to one another. Remember, at this point now we're talking about something that is measured in two different dimensions, if you will. So, oftentimes most things have several different sort of measures that they can do that we can take. In fact, the first day of class, I asked you to take several measures of a bag of M&Ms, right? So you had to weigh it, you had to count how many M&Ms were in there. You had to count how many of each color were in there, right? So that's several different dimensions or different variables that were captured for the same unit, the same thing. So that happens all the time. And so correlation then and covariance, both of these things, want to measure the relationship between these multiple variables for the same thing. Correlation then does two things. Measures the direction of this association and also the strength of these two things. The direction, that means, are they positive? One goes up, the other one goes up? Or does one goes up and the other one goes down? That would be a negative correlation. So we can have either a positive or a negative correlation, just depending on the sign of the number, the correlation coefficient. Correlation coefficient goes from -1 to 1. And then the strength of the relationship says as we get further away from 0 in both directions, we have a stronger correlation. So covariance is the same idea. The problem is it's not in a nice, pretty unit like from -1 to 1. In fact, it's not really in any kind of unit at all. We're not going to work through the math too much in this class. In fact, for covariance, not at all. But covariance really is not this pretty -1 to 1. It will go all kinds of values. It could take any value, depending on what the unit of the measures that we were using. So, in that discussion, covariance is not that useful by itself. In fact, most of the time you would convert covariance into correlation. In fact, they can convert back and forth, sort of like variance can be converted to standard deviation and back and forth. Same thing with correlation and covariance. They can be converted back and forth to one another. Covariance, on the other hand, is used quite a bit in other statistics. In fact, when we start talking about regression, then we can kind of see that covariance plays a pretty big role in that. All right, so that's it. So this is then sort of the big topics under descriptive statistics. So what I'd like to do now is go through and make sure that we can do all of these things, probably not covariance, but all of these things in a number of different ways in Microsoft Excel using this M&M data. So go download this M&M data. It's just called M&M data. It should be on the website. And what I have here then, let me readjust a little bit, is quite a bit of data. So I've been doing this for several years now. And so it looks like I have about 218 different observations, 218 different bags of M&M that have been measured for me over several different classes. And if you remember what kind of measurements we took, we asked, what's your favorite M&M color? I don't think it was in this order, but what was your favorite M&M color? How much does your M&M bag weigh in grams? What kind of M&M did you choose? And you could choose either peanut or plain. How many M&Ms were in your bag? You had to count how many were in there. How many blue, how many red, how many yellow, how many orange, how many brown, how many green? What's your guess at the M&M color that's most prevalent? And what branch of service you're in. Okay, so first of all, let's talk a little bit, just remind ourselves how data is set up. Most of the time in sort of databases or Microsoft Excel. So most of the time data is set up in a way where each row, remember rows go this way, is one observation. So in this case, each row is one bag of M&Ms, right? Each columns going up and down. Remember columns going up and down, that's the way I remember that as these are like columns that hold up buildings, coliseums holding up buildings. Columns are variables or measures, different types of measures or different types of things that were captured for that one, for each and every one of the rows. Right? So that's what we got. We have observations and variables. That's what we're going to think about. So if I wanted to know what the average of all the M&M bags were, well, I'd have to look at all of these numbers going straight down this column B. Right? That's what we'd want to look at. All right, so another thing about data then, we talked a little bit about in class, there are really three types of data. The first one that we talked about is called discrete data. Discrete data are the type of data that are sort of put into chunks, and oftentimes these chunks are actually words, right? So here I said, what's your favorite M&M color? Yellow. I think this is all sorted, so yellow's all at the top. Red, you can choose all kinds of colors, or all the colors that were M&Ms. That's data. It's discrete data, right? Because you can't have like, well, my favorite color is yellow and a half, or yellow 0.345. You can't do that. So it's discrete. It means it's like sort of, it's either this, or it's this, or it's this. It's discrete. That's what discrete means. It's very separate, separate things. So discrete data is the first type of data. Discrete data is oftentimes words, but it doesn't have to be. It could be numbers, all right? Oftentimes numbers represent different things. They don't actually mean what a number means. They could mean something else. So I could say, if you chose yellow, I could recode this to say yellow, we'll just make it 1, the number 1. But it doesn't mean I can take the average of all of these numbers and find some sort of average color of favorite color or something like that. As far as means, I could take modes, but I couldn't take means. That's it. Discrete data. Second data then is continuous data. Second type of data, continuous data. And continuous data is the type of data that are really just kind of numbers that we're used to seeing. But more precisely, continuous data means that we can break up our measurements into even more and more and more and more preciseness. Right, so think of this next one. How much does your M&M bag weigh in grams? And I wrote to 1 decimal place. Well, I could say go to 2 decimal places, go to 10 decimal places, go to 100 decimal places. And if I had a powerful enough scale, one that was that precise, then I could do that. And that's the sort of one of the features of continuous data, is that I can get more and more and more and more precise. But really, continuous data you can think of as just numbers that sort of go across a scale. So think of like a ruler, right? So we have a ruler. Any measures we take on a ruler is continuous data, because I can be sort of anywhere in here. It's not discrete. It's not sort of chunked, but it's continuous all the way across. And then the third type of data, which we actually don't have in here, is it's called ordinal data. And ordinal data won't show up a lot in our class, but it is the third type of data. Ordinal data is really, this word ordinal has order as a sort of a root to the word. Order, it's just data that tells us the order in which something might happen. So the example of this is we might capture for a race not only the time of a runner, maybe their gender. So time would be a continuous, gender would be a discrete data. But we might also capture their place, right, in the race overall. Did they take first place, second place, third place, fourth place, 27th place, 319th place, right? So those places are ordinal data. And the reason why they're slightly different than continuous is because we don't really know the difference, the distance between first place and second place, and between second place and third place. And in fact, they're probably not the same, right? There's not an equal amount of distance between first place and second place and third place, and go on and on and on. They're all sort of different intervals, and so this is ordinal data, which is something just fell behind me. Whoa. All right, so that's why it's called ordinal data. We don't want to use that a lot in this class, but it's a different type of data. Let's get into this data, though. So the first thing I'd like to do is actually just count how many M&Ms are here. So I'm going to write this out. I'm going to have like a total column here. I'm going to do peanut. So I'm going to go here and just grab one of these peanut yellow bags, paste it right here, and then find one that says plain. Whoa. There we go. There's a plain. All right. And I want to just know how many of each of these there are. But first, let's just figure out the count of everybody. So this is easy. Equals count. So counting is not really something that showed up under descriptive statistics, but it is something that we need to know how to do in Excel. We oftentimes just want to know how many observations we have in here. So this count function then just actually counts how many numbers it sees. All right. So if I tried to count these words right here, I hit enter, it would say, well, there's none of them there. There is a function. If I say count A, then it would count it, right? But let's just stick with count and do this over again. All right. So count and then F2. It doesn't really matter what we count because it's just counting, right? So we could count this column right here. We could count this column. Doesn't really matter. Let's count this one right here, though. How much does your M&M bag weigh in grams? All right, so Control-Shift down. Highlight all of that, hit Enter. It says we had 215, but actually I think there's more than that. If I go up here and hit Control down, there's 219 rows, and the first row doesn't count because it's got variables. So there's really 218. So something's going on here. And I just got done saying that if there's words in something, it won't count it using the count function. So I think that's what's happening here. Is there's actually some data in here that needs to be cleaned up a little bit. And we'll see that. So let's go up here to this. How much does your M&M bag weigh in grams, and sort it. I'm gonna go over here to this sort and filter, and click sort from A to Z. Let's do sort Z to A. There we go. So if I do sort Z to A, I get these three guys up here. These two have a letter in them. Someone was an overachiever and wrote G for grams. And then this one, somebody is probably likely somebody from Europe or something, put a comma instead of a decimal place, which is actually standard in some countries to use commas. So here we go. So let's go in here and hit F2, delete the G's, and turn that comma into a period. Oh, look at this. This has already changed to 218. It was 215 before. So this is the cool part about Excel. This is actually dynamically connected to the other data, which means as I change the data, then the formulas that we have written, as long as they're referring to cells, will dynamically change, right? So this is the power of sort of spreadsheets, is that I can change something in the data, and then all my calculations will just automatically update, as long as I use my cell references appropriately. So we got to get practice using cell references instead of actually typing numbers into a function, into a formula. All right, so we have 218. The other thing I noticed, I'm going to sort this again from A to Z. Actually, no, let's do that a little later. All right, so the next thing I want to do then is count the number of yellow M&Ms and the number of plain M&Ms. Sorry, the number of peanut M&Ms and the number of plain M&Ms. So how do I do this? Well, I can use this equals COUNTIF function, which says counts the number of cells with a range that meets a given criteria. So that's what we want. So what's my range? Well, in this case, it actually is okay to count words. I don't know why the regular count function won't let you do that, but this COUNTIF you can. So I'm going to say count all of these words right over here, all these cells that have words in it. Hit comma and say, well, what's the criteria? Well, my criteria is, the first one is I just want to count how many peanut M&Ms were there. All right, so actually I can just point at this cell right here and say, go look for anything that looks like this cell. That's what this criteria is just saying. That's it. I just point and say, make it look like, see anything that looks like what's in that cell. And that's it. So I can hit enter, and there we have 145 peanut M&Ms. I'm going to do one more thing though. Hit F2 and get it back into the cell. This range, I'm going to hit F4 a couple times on both of the numbers and lock them in. Remember, put these dollar signs, make them absolute values, which means that when I copy and paste it down, which I'm going to do in just a second, it will keep that same range. It will still count within that same range, still do any sort of calculation within there. So let's do that. Control copy, Control V. And then hit F2 just to see what happened. So if I hit F2, I can see, well, here's N4. So that guy copied down. Why did it copy down? Because I didn't hit F4 around the peanut, which is what I wanted. But these guys, this blue thing over here, right, those ones stayed where they were because I had those dollar signs in there. Great. So I had 145 peanut M&Ms that have been observed and 73 plain M&Ms. Let's do now the mean of weight. Let's first start with the total mean of the weight of M&Ms. So this was pretty easy. Equals average. Average is the function in Excel that actually takes the mean of things. All right, so let's do that. So here's the mean weight up here. Control Shift down. Enter. Whoops. There we go. So 50 grams. 50.48 grams. Good. Now let's find the mean of just peanut and the mean of just plain. Now there's several ways we can do this. We'll do it another way in a second. One way that might be sort of simple brute force way is to just sort the data, right, by peanut and then just take the average of peanuts. Sort the data by plain and just take the average of plain. Now that's okay. The problem with that is that if you're taking averages of ranges, right, if I'm actually highlighting a bunch of data, then if I sort the data again, that range actually stays there, and if things get moved around, then now you're not taking the average of the right thing. So it could get a little bit sticky doing that way. So let's actually think of a different way to do it. So there's this average if function. Whoa. Average if function. Average if has three things: range, criteria, and the average range. So what is this? Range and criteria. Well, that looks a lot like the if or the count if function. Right? So same kind of thing as a count if function. And then finally, well, what does it you want averaged? So it's saying, all right, go tell me, what you want me to look for. And then after I found what you want me to look for, tell me what you want me to average. So this is actually going to involve two different columns is what's going on here, right? Because we're going to go and say, well, here's our range. All of these peanut planes, what kind of M&Ms did you choose? Control Shift down. Hit F4 to lock that whole thing in. Comma, what's my criteria? Well, go look to see if it's what's in this cell, this peanut yellow bag. And if it is, then come over here and use this number right here to find the average. Which means I want you to go and take the average of how much things weigh, right? So that's my average range, is this whole column. Control Shift down, hit F4 again, and lock that in. So you can see we have this first range is locked in with all the dollar signs. The second one is not. This is the criteria because it's just this one cell. And I'm going to copy and paste him down in just a second. And then my average range is also locked in because I want that to stay the same when I copy and paste it down. So that's it. Hit enter. So I have 51 for peanut M&Ms. Control C, Control V. 49.24 for plain M&Ms. All right, so we're doing good so far. All right, so we talked about in class that my theory was that peanut M&Ms were somehow sort of superior than plain M&Ms, right? And I'm going to sort of start a new little thing over here. And the reason why I said that was because I thought that with peanut M&Ms, you would get more than was expected more often, or you would get more than what was expected for peanut M&Ms. And expected, I mean, if we looked at the bag of M&Ms, it will tell us what was the expected weight should be. In fact, I got it written down here. So the expected weight for peanut M&Ms is 49.3. Plain M&Ms was 47.9. All right. So what I want to do is actually figure out what the average error, or really the average difference between expected and actual for all the peanuts. Find the average for all the peanuts, and then find the average for all the plain. So I did this in class, I think the first day or one of the first days, and I sorted the data and then sort of just did it that way because that was a quick and fast way to do it. Now I want to show you a different way using sort of a little different technique. So first I'm going to insert, let's do it right here. Insert a new column right after what kind of M&Ms did you choose? And I'm going to call it, let's see, actual minus expected. Actual minus expected. That's what I'm going to call it. It's kind of like an error thing. And this is what I want it to do. So if the M&M bag was peanut, then I want it to take this number and subtract this number over here, this peanut number. If the type of M&M was plain, then I want to take this number and subtract 47.9. So there's a little bit of logic going on in here. So we'll use this function called the if function. The if function then does essentially really one thing, but it does it really well, is you give the if function some logic test. And the logic test has to have only two possible outcomes, either true or false. That's it, true or false. So you say, is this true? And if it is true, then it says, well, if it is true, what do you want me to do? And then you sort of put in whatever you want it to do. If it's not true, then it must be false, because there's only two possible choices in this logical test, true or false. If it's not true, then it must be false. And then what do you want me to do? All right, so that's exactly what we have here. So what we're going to say is, go look in this cell right here, the one right next to it. And the logic is, does that equal what's over here? right? What I've written down over here. I'm going to hit F4 for that one, right? Because I'm going to copy and paste this formula down. I don't want that one to move around. So if it does equal what's in 09, what's over there, comma, so it says if that's true, if C2 does equal 09, then what do you want to happen? Well, then I want you to take this number over here and subtract the expected weight for peanut. F4, hit F4 and lock that number in. Right? Because that's just assuming it is a peanut M&M. If the first thing says, is this a peanut M&M? Yes. If it is a peanut M&M, true, take this number and subtract 49.3. Then I hit comma and says, well, if it's not a peanut M&M, there's really only two choices, plain or peanut. So that's it. If there are multiple choices, we'll see this some more time in class. There's different ways to do this, but let's just say there's only two choices here. Then what do you want me to do? Well, I want to take this number at that point and subtract it from our plain weight down here. Right? Hit F4 and lock that one in too. And that's it. You can close that bracket. So again, let's look through this. So I'm going to do a logical test. See if C2, whatever is here, equals 09, this cell, this says peanut. If that's true, if that comes back and says, yep, that's right, then I want you to take this number and subtract it from the expected weight for peanut, because it must be a peanut M&M. Otherwise, comma, if it's not true, then it's false, then take this number and subtract it from plain. All right, let's do this. Hit enter. 4.1. So that's the difference between 53.4 and 49.3. So this bag was 4.1 grams over. Let's just paste this guy down. Great. So here's one that's negative, right? So this was a plain, 47.8. It was supposed to be 47.9, so that's negative 0.1 off. So that just means that it's actually smaller than what was expected. All right, so there's our actual minus expected. So now let's just do this mean of weight over again, but instead we're going to do the mean of error. There's one way to do this, actually, that if I was working on this, I would probably do it this way, just because I'm lazy and I like to do things a little sort of lazy way. I could rewrite this average if function like we did just a second ago, but I've already written it once. It's right over here, so I can hit Control-C and then Control-V. But I can automatically know it's not going to quite work. Why? Well, let's hit F2. Remember, the average if function had a range and then a criteria. So the range is to go look at what type of bag it is, and the criteria should be, it should be this cell. So remember, I copied it and pasted it over, so it shifted that whole cell over. I can just grab this and drag him back. Say, nope, actually go look at the peanuts. And then the final thing is, well, where do you want me to average? Well, it used to be that I wanted you to average how much does your M&M bag weigh. Well, now I actually want you to average what's over here in this actual minus expected. So I can go over here and hover over the square, the purple line, and as I do, my cursor changes to like a little something different. I can click on that and drag him over to actual minus expected. Let go. Hit enter. There we go. So there's my mean of error for peanut. Copy, paste, and then I can do it for total. Same way. So, but now it's taking the average of this, which it can't do, so I can grab him and drag him over and be done with it. All right, so peanut M&Ms on average we had a mean of an error of 1.8. A plain had an error of 1.3. All right, so that was sort of what I expected. Okay, so this is cool. Now, the problem is if I want to do like a standard deviation, or if I want to do some other things, I actually can't do it. There's no standard deviation if function, and so it makes it a little bit difficult to do it this way. So I would have to do the sort of sorting trick, which is sometimes, like I said, it kind of gets messy. If I sort things several times, then things probably don't work the way they should. So sort of a smarter way to do this then is with a pivot table. So let's get some practice using a pivot table, and we'll see in a minute why a pivot table can actually do even more things, even more powerful. So how do I do this? So I have to click in my data somewhere in the data, just anywhere. It doesn't really matter. And then go and say Insert Pivot Table. And it should automatically kind of highlight what it sees as a sort of a whole bunch of data next to it, one another. A pivot table has to have data set up in this way, right, where I have variables on columns and observations on rows. And each variable, the top row of each variable should always be the variable's name. Right, so if it's actually some data, it will actually use that data as the name for that variable, which isn't what you want typically. usually, again, it will actually select all the data. If it doesn't, you can click on this and select it. So that's it. Click on OK, and it creates a new tab for you. And here we go. So let's open this up so you can see this. I might have to scrunch this over a little bit so that this fits within what you can see. Oh. All right, there we go. So what do we have here? Up here are all the variable names of the very top, and this is sort of just like what we can what we can use. And then there are 4 places here that we can drop stuff. So the first one that's kind of most important was what's down here in the corner. These are just what the calculations we're going to do. So remember, the first thing we did was try to figure out what the count of something was. So I could drag anything in here and ask for it to tell me the count of something. It doesn't matter what it is. Counting, remember, is just counting how many times something showed up in there. So let's just grab this, what's your favorite M&M color, and drop them in here. And it says right here that it is made that into a count of what your favorite M&M color is. It's just done that. And we come over here and see what it is. Well, it's 218. We already knew that, so that's great. So now, though, pretty easily we can separate that by any discrete variable. Right, so now I can throw in any discrete variable in the column or in the row, and it will just separate that. It will just sort of split it into the different discrete things. Right, so what type of M&M did you choose? Well, let's grab that and drag him there. Oh, very cool. So it just automatically separated it by peanut and plain, 145 and 73, which is what we had figured out from a second ago. Perfect, so we did that done, just like that, got that fast. No count if function, no writing, just did it. It was really fast, and we're done. All right, let's do another thing then. So let's figure out how much does your M&M bag weigh, and let's throw him down here in the values. And actually, we want to figure out what the average is of that, right? So by default, when you first make a pivot table, if the variable over here is a number, and we drop them into the little summation thing down here, it will turn it into a sum. It will think the default is a sum. If it's a word, and you drop it in here, the default is a count, right? So you have to be really careful. So this says sum of M&Ms. That's not really what sum, it just means it's adding them all up, right? Well, what we really want is the average, which is adding them all up and then dividing by the total number. So actually, we have everything here. We could figure out the average because we have the sum, and we could just divide by how many there are. That's what's going on. But there's even a better way. So let's click. How you do is you click on this little arrow down here, say value field settings, and say give me the average. Click on OK. So there we go. So we got the average of 51.10 for the peanut and 49.24 for plain. Great. I'm going to scrunch this down a little bit so it doesn't take up too much space. The last thing we did then was take this actual minus expected. We can do the same thing, drab him in there. The default is sum first. Let's make him value field settings, make him an average. Click on OK. Sorry, it's kind of hard to see. There we go. 1.8 and 1.3. So that's exactly the same answers we got before. Now here's the cool thing. What if I want to take the standard deviation of this actual minus expected? Right. I also want to know the variance of these different of this error. But I want it separated by peanut and plain. Now, that's important to have it separated. Well, I can just grab this actual minus expected and drag him, put him back into this this values thing right here. Drop him in there again. Like I can put several versions of him, keep throwing him in there, and that's okay. Again, first the default is to make it into a sum. But if I click on the arrow and say value field settings and say, well, I don't really want to count, and this time I don't want an average, but if I scroll down, I want a standard deviation. There we go, standard deviation. Not standard deviation P, that gives me the population, but I just want the standard deviation. This is a sample. Sorry, this keeps getting squished down every time we do this. There we go. The standard deviation then separated by peanut and plain. So peanut M&Ms actually have smaller standard deviation. Slightly than plain, which is actually kind of surprises me a little bit. I would think that the plain M&Ms would have a smaller sort of spread than the peanut M&Ms, but we'll find out maybe later on in this class whether or not there's actually a real actual difference between these standard deviations, or if it's just due to randomness, which it could be. All right, so that's it. So let's do one other thing. I'm gonna get rid of a bunch of these things. The only thing I'm gonna keep is the average. So if I want to get rid of something in a pivot table, I just grab it and throw him back up here. Grab him and throw up there. So I got the average. So by the way, this question comes up a lot. If this over here goes away, let me show you how to make it go away. If I click on another cell that's not within the pivot table, then that thing is gone, and you're like, oh no. So how to bring it back is we just click inside the pivot table, and then it comes back. All right, so if it's disappeared, that's what's happened. All right, so let's do something else. What if I wanted to ask not only the average across peanut and plain, but I wanted to know the average of people in the Navy who chose peanut M&Ms? I want to just know what there is. So that would be sort of dividing the data even further. So peanut and plain, and then I want to divide all the data by the branch of service that you're in. And then I want the average within each of those, the average weight of those. So how do I do that? Well, here's this variable here called what branch of service you're in. So I can grab him and drag him into the column. And let's just see what happens here. All right, cool. So we still have peanut and plain right there. But now we have all the branches. And here in the middle, what we have in the values is what's happening is still the average of how much your M&M bag weighs in grams. So what is this thing right here? Well, this is the people that were in the Air Force who chose peanut M&Ms. Their average was 51.8625. So very cool. In this case, everything looks pretty much the same, except for this Army right here. It seems too low. All right, so these ones are all just about exactly the same. So it doesn't matter which branch of service you're in, the peanut M&Ms all weigh the same, which is what we'd expect. Why would the branch of service influence anything? Plain M&Ms, that looks pretty close to the same too. They're all around 50, except for Army. It's 47.31, so something goofy's going on here. So if I want to investigate what's happening in this cell, in fact, this happens for any pivot tables. Once I have sort of a little cell in here, I can double click on this cell and it will just pull up. It will make a new data sheet just with the data that was used to calculate that cell. So that's cool. So let's do that. Let's double click on that cell just to take a closer look. So it's just created people that had plain M&M and that were in the Army. That's it. So this is how many there were. And here's our weights. So you can probably see, and I can see it right off the bat, this is not right. Like someone didn't really have 4.9 grams. It was likely 49 grams. It was just mistyped or something. Pretty likely 49 grams. So let's fix that. We have to go back to our original data. So remember, this created a new data sheet called Sheet 2. So click on All. That's where it was. Go to this, how many M&Ms, how much does your M&M bag weigh in grams? And sort that from Z to A. Nope, sort it again from A to Z. Let's get the small ones on top. There's actually two of these 4.9s. One of them is plain from the Army. One of them is peanut from the Navy. So there was two of them. So we can't just blame Army guys. We can't just blame plain M&Ms. It sort of seems that there's two people who made the same mistake. So let's fix that. Let's just assume it was 49 for both of these. All right, so that actually changes things. So look, this actually changes quite a bit over here. We can see that dynamically changed. Remember, this is connected to that data. So that's kind of cool. So dynamically change stuff. It changed these ones as well. The same thing happens with a pivot table. However, it doesn't automatically do that. It will. We have to do one extra step. So you can still see this is still 47.3, and it should be something different. If we go into Options and say Refresh. So first of all, click on the pivot table, somewhere in the pivot table. And then up here where it says Pivot Table Tools, click on Options, and then click on the little guy that says Refresh. We click that. Then you can see right here, there it went back to 49.51, which is pretty much what we expected. Remember, it was 47 before. So now they're all around 50, and here these ones are all around 51. So that's very cool. So what if I don't care about average, but again, I just want to know the count? I can change this value field settings to count, and click on OK. So there we go. So now I can know how many for each of these cells, it might be interesting, right? So you can be guaranteed on the exam, the questions won't be as simple as, all right, find the average of something. It will be something like this. Find the average of, peanut M&Ms for Marines, something like that. So you'll have to do something like this. You don't have to use pivot tables, but if you do some sorting and sort of do a brute force thing, There's just more chance for error. Pivot tables are just something that you can just really manipulate data really quickly and fast, and it just makes things a lot easier. So get a little practice using pivot tables. All right, so let's go back. I think we've done quite a bit on our little summary. We talked about mean. We haven't done median and mode yet. We'll do that in a second. We haven't talked about percent and quartile. We did do standard deviation. You can do variance the same way. And we haven't done range, and we haven't done correlation. So let's do those things pretty quickly. Go into peanut tab. So instead of the all tab, let's just look at the peanut M&M. So in this case, I've actually separated the data just by peanut M&Ms. I have to fix those ones that were wrong before. So go up here to how many M&M bags you had. Sort from A to Z. There's our 4.9. Let's change them to 49. And sort from Z to A. And there's our couple with G's in it. F2 to get into the data. All right, so let's do a few of these. Let's talk about the median, the mode. Let's do a standard deviation again. Standard deviation. Let's do the variance. What else do we got? Percentiles. So let's see, percentile and quartile. So let's do a percentile. Let's do like 15th percentile. Let's do the first quartile and the third quartile. And then let's do correlation between a couple things. And then that's it, I think. All right, percentile, quartile. Oh, we need to do the range and then interquartile range. So let's do the range and the interquartile range. And then finally correlation. All right, so we'll do all those things. So median, easy, equals median. And then find your numbers, right? So let's do the median. Let's do how many M&Ms were in your bags, right? So Control Shift down, highlight all that data, hit Enter. There it is. The median of how many M&Ms were in your bag is 19. The mode equals mode. I think actually the answer will be the same, which is interesting. Control Shift down, hit Enter. Yep, mode is 19. Standard deviation equals standard dev dot S, right? So dot S is for a sample, dot P is for a population. Everything we'll do in this class will be for a sample, unless I explicitly tell you, which it's pretty unlikely it's going to happen. So standard deviation dot S, and then highlight the data, Control Shift down, hit Enter. 1.58. So again, what is the standard deviation? It's the average distance from the mean of all. So in this case, this is in M&Ms, in how many M&Ms were in there. So on average, well, we could find the mean. Let's do that too. Mean. We already did this, but let's equals average. It's sort of hard to interpret a standard deviation without the mean. There we go. So the mean is 19.6. The mean of 19.6, but on average, all the other M&Ms are about 1.58. All the other bags of M&Ms are about 1.5 M&Ms away from 19.6. Interesting. So variance is the same, equals var.s, var.s, and then let's highlight this. Or there's actually another way to do this, right? So that's 2.53. We could also just take the standard deviation and square it. Square it is caret. That means raised to the power of 2. Same thing. If I find the variance, I can find the standard deviation just taking the square root. SQRT is square root function in Excel of the variance. There you go. So those two can just go back and forth. No problem. All right, percentile. So equals percentile dot inc. We're going to use that one in this class. Percentile dot inc. And that's for two things. The array, and then array is just another word for range. Excel goes back and forth between array and range. So we're going to use the same. How many M&Ms were in your bag? Control Shift down. And then K, it's just asking for what percentile do you want. And it has to be a decimal between 0 and 1. So I actually wrote 0.15 right next to it. So I'm going to just point my cell at that. Point at that cell. I could type in 0.15. In fact, that's fine, except for this. It's just not the best practice. So it's better to actually just point at cells, because then I can see what's happening just from cells, and I don't have to worry about what's written in there. So 18. In fact, the nice thing is I can change this on the fly. So I say, well, tell me the 19th percentile. It's also 18. Tell me the 27th percentile. Oh, whoops. Tell me the 27th percentile, 0.27. Oh, 19. Right, so I can go on the fly. I can just change the function right here without having to go inside the cell and actually sort of changing the function. All right, quartiles. Remember, the quartiles is the 25th percentile. So we can figure it out right here. 0.25, it's going to be 19. But let's do it a different way. Equals quartile, spell it right. So by the way, this happens for any function. When I start typing, Excel will just tell me, well, here's the things that sort of you'll likely mean. So here's quartile.inc. That's what I want. I can just use my arrow keys to sort of go down there and hit tab, and then it will just write everything else out for me, so I don't have to sort of keep writing. Quartile, so my array up here, Control-Shift down. I'm going to hit F4 because I'm going to copy and paste this down in a second. And then hit comma. So here's my different choices I can do. I can do 0. If I put in 0, that's actually the min. 1, the first quartile, is the 25th percentile, it says there. 2 is the median, which is the 50th percentile, which actually we know is 19. 3 is the third quartile, which is 75th percentile. And 4 is the maximum value. So let's just point over here. I wrote the number 1 right there, so I can just point at that cell, and that will give me the first quartile. So I can hit it 1 and 19. Perfect. Copy it and paste him down. And then I get the third quartile. So third quartile is 20. So that's interesting. So the median, remember, is 19. The 20th percentile is also 19. And the mode is also 19. So 19 shows up a lot in our data set. Right? So there's a lot of times where you just have 19 M&Ms. The mean is 19.6. All right. So let's find the range. Remember, the range is just the max minus the min. There is no equals range function. Nope, nothing there. So if you start typing and nothing sort of shows up after it, that means there's no such thing as what you just wrote. But we can type equals max, highlight all the data. If I do that and hit enter, it just gives me the number. The max that we found then is 30. I can keep typing though. So if I found the max, found the biggest possible value, I can keep typing in that cell minus the min. Right? And then come back up here, Control-Shift down, hit enter. Yes. 14. So 14 is our range. That's the distance from the very biggest to the very smallest. 14. Interquartile range. What is the interquartile range? So that's the difference between the 25th percentile and the 75th percentile, also known as the first quartile and the third quartile. So that's easy. So actually, we already did it right here. So here's the third quartile. I can just point at it minus the first quartile. Hit enter. 1. So there's an overall range of 14 across all the data, but if we just look at the 50%, the middle 50% of the data, all of those are within one M&M from one another. So that's actually pretty interesting. It's pretty tight, pretty sort of squished in there, right? So 50% of the data is only one M&M away from one another. Pretty cool. All right, final thing. Actually, 2 more things, but here's correlation. So I can type equals correl, and that will pop up this thing. Quartile is just the standard correlation for Pearson correlation. And there's two things. It just asks for 2 arrays, really 2 ranges. Remember, correlation is a coefficient of the strength and relationship across 2 variables. 2 variables. So in this case, I need 2 variables. All the other ones, I sort of just needed 1. So let's do this. Let's do how many M&Ms were in your bag. Control-Shift down, comma, and then let's do the weight. So we should say, I don't know, what do you think is going to happen here? Well, it makes sense to me that if I have more M&Ms in my bag, then I will have a heavier bag. So I think that these are going to be a positive correlation, and it will likely be kind of strong. But I don't know. I actually haven't tried this, so let's see what it looks like. So once I do this, I hit enter, and then go up. All right, so I was right on one realm. It is a positive correlation, meaning that as one goes up, the other one goes up. But it's not super strong. It's at 0.48, around 0.5. I always say a stronger correlation would be closer to like 0.75 or 0.8, something bigger than that. All right, so that's it. Now let's do one more thing about correlation. Actually, we'll do 2 things. First, before we do this, let's do one other thing. So, sorry, under data, there's this guy called data analysis. If this doesn't show up on your tab, you have to actually add it. Let me show you how to do that. Go under File, Options, click on Add-ins, and then down here on the bottom it says Manage Excel Add-ins. Click on Go, and then you should see something like this. Make sure that the analysis Toolpak thing is checked. That's it. I have some other things checked. Don't worry about that. But check the analysis Toolpak. We will use analysis Toolpak a lot in this class. If you're using a Mac, I got some videos. You got to go figure out how to do this a different way, and I'll send it in the email about how to do this analysis stuff. It does not work this way. So click on OK. Once you do that, this data analysis thing should show up. Should just sort of pop up. So let's take a look at what's in here. Data analysis. So this has a whole bunch of stuff in here. In fact, we'll end up using a lot of this. We're going to do this correlation one right here in a second. But first, let's do this descriptive statistics. Descriptive statistics. Click on OK. And this is the first time we've seen one of these boxes, but this is all. They're all going to look like this, very similar to this at least. There's going to be some place to go put in some input. It'll tell, and then it'll ask where you want it. That's what this output range is, and then it might have some other options down here. It will almost always ask you where if there was a label or not in the first row, and we will try to keep a label in the first row because it makes things prettier. Input range. So what this descriptive statistics thing is going to do is like output a whole bunch of the descriptive statistics, what we just did over here, all at once. Just sort of make them all at once. So let's do this. So click on this and say, let's see how many M&Ms were in your bag. Control-Shift down. And I included the label. Right, so I included that first one. Hit Enter. When I hit Enter, it takes me back to this box. And I can say labels in the first row. Yep, make sure you check that. Labels in the first row. And click on Summary Statistics, and that's all we want for this point. And then let's just make a new worksheet. So as long as the default is, do you want to make a new worksheet? I could give it a name over here if I wanted to, but I don't really care to. So click on OK. And then here we go. So this is what we got. So how many M&Ms were in your bag? Here's the mean. Standard error. We haven't talked about what a standard error is yet, but we will in a few weeks. Median mode, standard deviations, variance, kurtosis and skewness we're not talking a lot about. Here's our range, min, max, and then the sum and count. So this doesn't have the quartiles or the interquartile range, but it has everything else, sort of just done all at once. So this is kind of cool. The bad thing about this is not dynamic in the sense that if I change the data, this will not update. There's no formulas back here. All right? If you look at these are just raw numbers in here. There's no formulas back here. So you have to be careful. If you did change the data, you have to just redo this again, and then it'll just sort of repopulate. So let's do that. Something similar using the same data analysis add-in. So data analysis. Instead of descriptive statistics, let's look at correlation. Click on OK. So correlation, now we're going to do a whole bunch of correlations, a correlation matrix, right, across all these different colors of M&M bags. Right, I want to see if there's a relationship across the different colors of M&M bags. There are different M&Ms in different M&Ms. There's not a bag, different M&Ms. So what's my input range? Click on this. I want to start with blue, go all the way over to green, Control-Shift down. So I've highlighted all that data. So in order to do this correlation matrix thing, the data has to be next to one another, right? Because I only have one place to highlight it like this. Do that. Columns, labels in the first row, yep. And then let's just make a new worksheet, so that's okay. So that's all. We're on OK. And what do we get? So we get this thing that's a correlation matrix, and we saw this in our notes a little bit. So what's a correlation matrix? Well, it actually just tells us, the combination between these two variables. So here's a blue and a red. There's our correlation coefficient. Here's our yellow and a red. There's our correlation coefficient. Here's our brown and a yellow correlation coefficient. Right, so that's it. So it just gives us all possible combinations of the correlation coefficients. There's nothing on this other side. Why is there nothing on this other side? Well, it's because it's repeated. It's already there. Right, so here's brown and blue. Well, that's the same as blue and brown right there, 0.32, blue and brown. So the direction, which one comes first, we can't say anything about. We actually don't know what causes what, but blue, brown. So we can see the direction. Some of these are negative. Most of them are negative. Only a couple are positive. But there's none of them that are really strong. So there's not a really interesting story going on here. But we just want to use it to show how to look at correlation coefficients. All right, so that's it. So let's quickly go back to this and say we can actually do all this stuff now. Make sure you can get through and do all these things. Mean, median, and modes. You should be able to take a mean of all kinds of sort of complicated combinations of things. Not too complicated, but say like several different layers. Remember, like peanut M&Ms, Navy people who take peanut M&Ms. That's the kind of stuff you need to be able to do, at least for mean. Median mode, we won't do that. Oh, more stuff falling down. Percentile, quartiles, we did that. Variance, standard deviation, range, inner quartile range. Make sure you can do all that. Correlation, covariance is very similar to correlation. We won't do it yet in this at this point. We'll do it another time. So that's it. So we got to be able to do all this stuff for the exam, and so get a little practice doing that. And hopefully this helped. All right, that's it for this one.